So looking at number 1, for these questions, when we go left or right, that happens inside. If it says that we are going to the left, are we adding or subtracting? Adding. If we're going to the right, subtracting. And then up or down happens outside. If I'm going up, adding or subtracting? Adding. And if we're going down? Subtracting. Perfect. So let's look at number 1. We have a translation 5 units to the right. So the right, is that inside or outside? Inside. And am I adding or subtracting? Subtracting 5. So we're subtracting 5 directly to the x. So here we don't have any parentheses, but because it's inside, it happens directly to the x. So I'm going to take the x. I can put parentheses around it, and I'm subtracting 5. So this would be 5 times x minus 5 minus 2. Andrew, what could I do to simplify this?
You could distribute the 5.
Awesome. We want to distribute the 5 into the parentheses. So that'd be 5x minus 25 minus 2. What else could we do to simplify? Combine like terms. So what is negative 25 minus 2? Negative 27. So we have 5x minus 27. And then we would name this as our g of x function, just as the transformation. But the important part is the 5x minus 27. Any questions there? Let's do the next one. A translation 4 units up. Up happens inside or outside? Outside. And are we adding 4 or subtracting 4? Adding. Up means that we add 4 to the outside. So I just add 4 to the outside. And combine like terms if we have them. Do we have any like terms here? So what would our answer be? 3x plus 10. Awesome. Any questions here? Let's do number 3. We have a translation 2 units to the left. Does left happen inside or outside? Inside. Are we adding or subtracting? Adding 2 to the inside. So we add 2 directly to the x. So plus 2 directly to the x. So let's write it out. We have 3 minus the absolute value of x plus 2 minus 2. Can I simplify this a little bit? How? The 2's cancel. Plus 2 minus 2 ends up just being 0, so they cancel each other out. So I have 3 minus the absolute value of x. Any questions here? All right, and then for 4, 2 units down, inside or outside? Outside. Adding or subtracting? Subtracting 2 on the outside. So we just minus 2 on the outside. So I have the absolute value of 2x plus 3 minus 2. We want to combine our like terms. So what would our answer be here? The absolute value of 2x plus 1. Perfect. Any questions? Good with this one? All right, number 5. So if we have a reflection in the y-axis, what gets multiplied by a negative 1? Just the x. So we multiply just x by negative 1, or just by the negative. If we have a reflection in the x-axis, What gets multiplied by a negative? Everything. So number 5, we have a reflection in the y-axis. So what gets multiplied by a negative? Just x. So just x gets multiplied by that negative. So if I have a negative x plus 3, what does that turn into? Just positive x. So this would be g of x is equal to what? X plus 3. Awesome. Reflection in the x-axis, what gets multiplied by a negative? Everything. So we multiply everything by a negative 1. So our answer would be g of x is equal to negative 2 over 3x plus 4. Perfect, because we had to distribute the negative. A reflection in the y-axis, what gets multiplied by negative 1? Just x. So just x is going to get that negative. So here, g of x is equal to negative 5 plus the absolute value of negative x minus 8. So just the x gets the negative. And then again, we have a reflection in the y-axis. So what gets the negative? Just the x. So just the x is going to get the negative. So what would our answer here be?
The absolute value of -4x minus 1 plus 2.
Perfect. The absolute value of negative 4x minus 1 plus 2. Perfect. Good job. I think we have one more transformation. Oh, a few more transformations. We got our vertical stretch and shrink. What do I do when I have a vertical stretch and shrink? Multiply everything by our factor. So for number 10, we have a vertical shrink by a factor of 1/3. So everything is going to get multiplied by 1/3. So when I multiply everything by 1/3, what do I have to do? Distribute. What is 3x times 1/3? 1. 1 what? 1x. So just x. Perfect. What is 5 times 1/3? 5/3. We can just say 5 over 3. Awesome. If you need to write it out, if you're not sure what 1/3 times 3x is right off the top of your head, write it down. How do I multiply fractions? What do I need to do? Multiply straight across. So this would be 3x over 3, which simplifies to x. So again, if we're just iffy on our fractions, write it out. For number 12, we have a vertical stretch by a factor of 2. So what gets multiplied by 2? Everything. So everything gets multiplied by 2. So we have to be careful with our absolute values. What do I distribute the 2 to here? To the negative 2 and to the 4. Awesome. Remember, our absolute values act as brick walls. We can't distribute inside of them. So we just leave it outside. If you have a transformation happening inside your absolute value, you can put a transformation in there. But if you're distributing, you want to leave it outside. So this would be negative 4 times the absolute value of x minus 2 plus what? 8. Perfect. Andrew, yes? Yes. All right, 13 and 14, we have a combination of transformations. So we just want to make sure we apply our transformations one at a time and in the order that it tells us. So for 13, which transformation am I going to apply first? Up 5. How do I show that I'm going up 5? Add 5, inside or outside? Outside. So we start with that x plus 5. What's my next transformation? Shrink by a factor of 1/4. So what would I do next? We multiply everything by 1/4. Perfect. So everything gets multiplied by 1/4. So what would my answer be? All right, Ivana, what would my answer be?
G of x equals 1/4 x
1/4 x
plus 5/4.
plus 5/4. Yes. Cool, I know you said the same thing. Good job. Any questions here? All right, for 14. So we're starting with the absolute value of x. What's the first transformation that I'm going to apply here? Reflection in the x-axis. So what gets multiplied by a negative? Everything. Is it going to be inside the absolute value or outside? Outside. Remember, x-axis is outside. So that would be negative absolute value of x. And then followed by a transformation 2 units left. How do we show 2 units left? Plus 2 inside or outside? Inside. So that's going to happen directly to x on the inside. All right, so raise your hand. How would I write my answer here? Armani, you want to try?
Yeah, negative absolute value x plus 2.
Awesome. Perfect. All right, so that is all of our transformation questions. Do you feel good with 1.2? Question? Yes. So 2.1, we're still talking about our transformations. In the first part, 1 through 6, it says graph each function. We're going to save the graphing for the next page, but just make sure you understand how your graph looks when a certain transformation is happening. So let's go through our transformations. For number 1, if we're subtracting 2 on the outside, which way are we moving? Down 2. So we would take our parent function graph and just shift it down 2. Our vertex and everything would just move down 2. So this is just like a rough sketch of the graph. We're going to be graphing like more precisely on the next page, but this is how it would look. For number 2, if we are adding 1 to the outside, which direction are we going? Up, how many? Up 1. So we would just take our parent function, the green graph, and move it up 1. For number 3, adding 1 on the inside, which way are we going? Left 1. Number 4, subtracting 2 on the inside. Right 2. For 5, subtracting 5 on the inside. Right 5. And then 6, we have 2 transformations happening. So if I add 2 on the inside, I'm going to the left 2 and down 1. Awesome. For a question like number 6, if it asks me for the vertex, what would our vertex be here? -2, -1. Awesome. Remember, it's what we're adding on the inside, but we always have to flip the sign of the H and what we're adding on the outside. Yes. When Andrew comes back.
So number 6 is standard form?
Vertex form. It's vertex form when you can clearly see the vertex when the parentheses are there. All right, for number 11 and 12, we're describing the transformation of the parent function and identifying our vertex. So we want to just go through each transformation. When we multiply by 2 on the outside, what is that? Vertical stretch. When we add 3 on the inside, left 3. And then when we add 2 on the outside, up 2. And what would our vertex here be?
Negative 3, positive 2.
-3, +2. Awesome. So think about it when we graph it. Our vertex goes to -3 and up 2. So which direction did I just move? Up 2 and to the left 3. So if you need to plot your vertex to help you remember which direction you're going, do that. But just don't forget, you change the sign of the H. Let's do number 12. So here, remember, each of these is a separate transformation. So that minus, that negative that's being multiplied to the x squared, and the 5 are 2 different things. When we multiply x squared by a negative, is this the inside or outside? Outside. When there are no parentheses, it's on the outside. So a negative on the outside means what? A reflection on which axis?
Or the y-axis.
Outside is which one?
The y. It's not?
Raise your hand if you think the x-axis. Raise your hand if you think the x-axis. Don't be afraid. Raise your hand if you think the y-axis.
Right.
Raise your hand if you're just not sure.
Yeah.
So outside is the x-axis. So this would be x-axis. All right, now when we multiply by 5, is it a stretch or shrink? Raise your hand if you think stretch. Raise your hand if you think shrink. It's a stretch. Why is it a stretch? Because it's greater than 1. So this is a vertical stretch. So be careful, because some people like to think that it's -5. So you might think that it's a shrink because it's less than 1. But the negative is separate than the number. So it's a vertical stretch, because 5 is greater than 1. All right, and lastly, we have a -1 on the outside. So we go down 1. Now our vertex here. What would our vertex be?
1, negative.
Be careful.
The y.
Remember, it's what we're adding on the inside and what we're adding on the outside of the parentheses. So it would be 0, comma, -1. Perfect. Because we're not adding anything on the inside. Notice how that last one, number 11, had parentheses. 12 doesn't have parentheses. We're not adding anything on the inside. So there is no inside. So it'd be 0, comma, 1. Number 12 kind of looks like standard form. How could we find the vertex if it's standard form? -b/2a. Perfect. And we'll practice that on the next page. All right. Lastly, let's do 13. We want to write a rule for g described by the transformation of the graph and then identify the vertex. So we're starting with x squared here. So remember, we apply our transformation one at a time in the order that it tells us. So we have a vertical stretch by a factor of 3. How do I apply a vertical stretch to the factor of 3? Multiply everything by 3. So here it's just 3x squared. Start with the x squared and multiply it by 3. Bless you. How do I show a reflection in the x-axis? Negative on the outside. Followed by a translation 3 units down. -3 where? Inside or outside? Outside. So g of x is equal to -3x squared minus 3. So now let's find our vertex. So perfect. This one looks super similar to what we just did in 12. So our vertex would be 0, comma, -3. Good job, Coy. All right, now let's graph. So 2.2, we are graphing. So we have y is equal to -3 times x minus 1 squared plus 3. Is this standard form or vertex form? Vertex form. So we can clearly identify our vertex. Andrew, what would our vertex be?
1,3.
1,3. Perfect. What we're adding on the inside, adding on the outside, but we change the sign of h, the inside one. What would our axis of symmetry be? X equals 1. Don't forget the x equals. It's a line. So let's go ahead and graph that point. I go to the right one, up 3, and I'm going to put my axis of symmetry right through it. Before we find another point, just looking at our equation that we start with, do we know if our graph is going to open up or open down? Raise your hand if you think up. Raise your hand if you think down. Why is it down? Because the A is negative, so that tells us that it's going to open down. So it's helpful to know that our graph is going to open down. That way when we plot another point, we know that it's going to have to be somewhere where our graph opens down. If our next point is above, either our vertex is wrong or our second point is wrong. Andrew, question?
Yeah. Is that only when it's in vertex form or also in standard?
Also in standard form. So our A is in front of the x squared. So like for the next one, is our graph going to open up or down? Down. So it works for either one. It also works in intercept form too. All right, so I have my vertex, I have my axis of symmetry. I know that it's going to open down, but how can I find another point? Plug in a number close to the axis of symmetry, or close to the x in our vertex. So what's a number close to 1? 0. So let's plug in 0. So we're going to plug in 0 for our x, and we're going to do the math to find our y. So to find the second point, you want to plug in a number. When we plug in a number, make sure you follow your order of operations. PEMDAS. What does the P stand for? Parentheses. So we're going to do our parentheses first. 0 minus 1 is? -1. Thank you. What does the E stand for in PEMDAS? Exponent. What's -1 squared? 1. So -3 times 1 plus 3. What does the M stand for in PEMDAS? What's -3 times 1? And then lastly, what's -3 plus 3? 0. So what's our point that we just found? 0, 0. I plugged in 0 for x and got 0 for y. So 0, 0.
Does it matter whether we do like 2 or 0?
It doesn't matter what number you plug in, but the farther you go away from your axis of symmetry, the bigger your numbers are going to be. So if you could have picked a number like 5, but you would have ended up with like a really big negative number. So you want to stick close to the axis of symmetry. Once I have that second point, do I know where my third point's going to be?
Yes.
Where? Why 2?
Because it's the opposite.
It's the opposite. Remember, our axis of symmetry tells us that our graph is going to be symmetrical about that line. So whatever point I have on the left side, I'm going to have that same point on the right side. Once I have my 3 points, we can draw our parabola. All right, so here, is my vertex at the maximum or minimum? Max. It's at the highest point, so we have a maximum. What is the maximum value? 3. Just 3. It's always your y value, 3. What's our domain? All real numbers. And then what's our range? Y is less than or equal to 3. Why is it less than or equal to? Because our graph is pointing down. We're talking about y values that are less than 3. Because our graph is going down. It starts at 3 and it's going down. Andrew. All right, let's graph in standard form. So standard form, it's a little bit harder for us to find our vertex. You can't clearly see it in the equation. What do we need to do to find our vertex? Negative b over 2a. That gives us the first number in our vertex and the axis of symmetry. What's my a? Negative 3. What's b? 6. And c? 4. All right, let's plug it in. So we have negative 6 over 2 times negative 3. Be super careful with the signs and with the math here. I think a common mistake that most people made on the quiz, which I'm going to hand them back now, will be, was like the signs. They just made a little sign error, which threw off the math with the rest of it. So just be super careful with your signs here. So you have negative 6 over negative 6. What does this simplify to? 1. So what is 1? The x in our vertex. How do we find the y? Armani? Plug it back in. So we plug it into the x's to find our y. So you have negative 3 times 1 squared plus 6 times 1 plus 4. Make sure you follow your order of operations. Got to do the exponent first. Alexa, question? Question? Hans, question?
No.
Okay. So 1 squared is 1, and 1 times negative 3? Negative 3. 6 times 1? 6. So negative 3 plus 6, and 3 plus 4? 7. So what is 7? The y in our vertex. Awesome. What's our axis of symmetry? X equals 1. Don't forget the x equals. So let's go to our graph. We're going to go to the right one and up 7 and put our axis of symmetry right through it. All right. So we said that this graph opens down because our a is negative. How do we know where another point on our graph is going to be? We could plug in 0, but without plugging in a number. What's special about the standard form? The C. The C is what? The C is the other point. It is our y-intercept. That is where we cross the y-axis. So our C. You can definitely plug in another number and get another point. That totally works every time, but save yourself a little bit of math. Just look at your C. So our C is where we cross the y-axis. Once I have 2 points, do I know where the third point is? Where? The mirror. Same thing on the other side. So once we have our 3 points, we can draw our parabola. Is the vertex at the max or min? It is the max. What is our maximum value? 7. What's our domain? All real numbers. And what is our range? Y is less than or equal to 7. Awesome. Because our graph again is going down here, it's less than or equal to. All right, for the next one, what form do we have here? X-intercept form. So x-intercept form. So here, it doesn't ask for it, but it did on the quiz. So let's find our x-intercepts. What are the two values that we're going to cross the x-axis at? -2 and +4. Remember, we flip the signs of the numbers. So I cross the x-axis at -2 and +4. Now, how do we find our vertex? Awesome. We add the two x-intercepts together and divide by 2. We want to find the middle of these points. Andrew, how else could we find the vertex?
Oh,
How did you find it on the quiz?
I just like counted.
You can just count. Count the middle if you need to. It's going to be the very middle of these 2 points. But algebraically, mathematically, we would add them together and divide by 2. So I have -2 plus 4 divided by 2. Amanda, question?
No, I was gonna ask you. No, oh, wait.
Okay. So we have 2 over 2, which is 1. So what is 1? The x in our vertex. How do we find the y? Plug it in. We're going to plug it into the x's. So I have 1 plus 2 times 1 minus 4. 1 plus 2 is 3. And 1 minus 4? 3 times -3? -9. What is -9? The y in our vertex. So let's plot our vertex. We're going to go to the right one and down -9. Bless you. What's our axis of symmetry? X equals 1. When we draw our graph here, is our vertex at the max or the min? The minimum, because it's at the lowest point. What is our minimum? It's always the y, which is -9. What's our domain? All real numbers. What's our range? Y is greater than or equal to -9. Perfect. Here it's greater than or equal to because our graph is pointing up. So lastly, we're going to look at 3.6. Let's do number 7. So here we are graphing inequalities. When we see the inequalities, what do we need to remember to do here? Shade. And also, if we have a less than or equal to or greater than or equal to, what type of graph are we going to have? A solid graph. So a solid parabola. If we have a greater than or less than, what's the shape of our, or what type of graph do we have here? A dotted parabola. So number 7 is a good one because we have both forms going here. So for the first equation, we're going to graph one at a time. Let's start with our first one. So here we have vertex form. Andrew, what's our vertex here?
That would be 2, 4.
Awesome. 2, 4. So we go to the right 2 and up 4. Now, how do I know what other point I'm going to have on my graph here? What do I need to do? Plug in a number. What number can we plug in? Sure, we can plug in 0. Anything close to our axis of symmetry, our axis of symmetry here is what? X equals 2. So anything close to 2. 0 works, that's fine. 0 is going to be an easy number to plug in. So we're going to plug in 0. We have -0 minus 2 squared plus 4. With PEMDAS, what are we going to do first? The parentheses. 0 minus 2 is -2. What's the E in PEMDAS? Exponent. Make sure you do the exponent. You cannot distribute that negative and turn it into a positive 2. You got to do the exponent first. -2 squared is 4, and that negative on the outside makes it a -4. And what's -4 plus 4? 0. So our point would be 0, 0. Which means that we're going to have the same point on the other side of our axis of symmetry. Is my graph here going to be solid or dotted? Dotted, because it's just a greater than. It's still correct, but like your graph will still have the same shape. You're just going to have like a different key point. But like, what number did you pick? 1?
Yeah, 1.
Did you get 2? when you plugged in 1. So your graph probably just had those points instead, but it would have the same shape about.
Oh, I graphed it wrong. So that's why I'm confused. Okay, yeah, but I got it. Thank you.
So you can plug in whatever number you want. Your graph's going to have the same shape. All right, next. What do we have to do next for this one? Shade. How can we tell where we're going to shade, Andrew?
You can like plug in a point that's like anywhere inside the parabola.
Okay. What's a point inside of our parabola?
1, 0.
1, 0. That works. That's inside. So what am I plugging in?
You're gonna plug in like your 1 for the x values and then your 0 for the y values.
Awesome. So we pick a point. That's going to be our x and y. So Andrew said 1, 0. So I'm going to plug in 1 for x and 0 for y. So if 0 is greater than negative 1 minus 2 squared plus 4. So 0 is greater than, this would be negative 1 squared plus 4. Negative 1 squared is 1, but that negative on the outside makes it a negative 1. And negative 1 plus 4 is 3. Is 0 greater than 3? No. So where am I going to shade?
Outside.
On the outside. Any questions there? All right, now we need to graph the second equation too, and we keep the overlapping parts. So how do I find the vertex in my second equation? Negative b over 2a. What's our a? 1. What's our b? And c? Negative 4. So we have negative 2 over 2 times 1, which would be negative 2 over 2, which is negative 1. So the first number is negative 1 in my vertex. How do I find the second? Plug it in. So I have negative 1 squared plus 2 times negative 1 minus 4. Negative 1 squared would turn into positive 1 minus 2 minus 4. So negative 1 minus 4, which is negative 5. So the second number in my vertex is negative 5. So I'm going to go to the left to negative 1 and down negative 5. How do I find another point on my graph here? I can plug in a number close to the x, close to my axis symmetry, or how else? I can use c as the y-intercept. So I've crossed the y-axis at negative 4. Do I know where my third point's going to be? Where? The mirror of it. Same thing on the other side of my axis of symmetry. Is this a solid graph or a dotted graph? Dotted. We're going to have a dotted parabola. Because it is just a less than sign. So dotted parabola. What can we do next? Shade. We want to find out where we're going to shade. How do I tell where I'm going to shade? I can plug in any point I want. If we want, we can stick to points inside of our parabola. So what's a point inside the parabola? 0, 0. Awesome point to choose. If it doesn't fall on your parabola, I would always pick 0, 0, just because zeros are going to be the easiest number to plug in and do the math with. So we have 0 is less than 0 squared plus 2 times 0 minus 4. So we get 0 is less than negative 4. Is this true? Is 0 less than -4? No, it is not true. So where am I going to shade? Outside. So we're going to shade outside of our parabola. But what's the only part that I'm going to keep? The overlapping part. So I shaded this in blue and pink. So I'm only going to keep the purple part. So I want to make sure I erase the part that's not overlapping. So we keep the graphs, but we erase the shaded part that's not overlapping. Yes.